Hey guys, hello everyone. This is Nurul and I am a verified educator at an online learning platform that is an academy. You can access my videos over there as well. So if you're preparing for CSIR NET, GATE or IIT JAM, any of these exams, you can access my videos over there as well. These are going to be very helpful in your preparation, right? So in order to access my videos, what you have to do, you have to download this Unacademy Learning app and you can search for my name, that is Nurul, or you can go directly to my profile from the link given in the description. That's all for this. Let's continue with the video. Hey guys, hello everyone and welcome to the channel. So in this particular video, what I'm going to do is I'm going to take certain questions from your GATE 2018 and basically I'm going to take these numerical answer type questions. Okay, now I got many requests from you all to make video on your unit conversion, but to be very frank, like I was very confused that how to make a video for that, right? If I will tell you that 1 meter is equals to how many centimeters, or like 1 kilojoules is equals to how many joules, so that will be a very, like, that will be not a good practice, because that will be not a, like, that will be not for our level, right? Because we are preparing for GATE or CSIR, so that is not our level, that we will be reading out those basic things. Okay, so those things are already over there in the books and on internet as well. So what I thought, that I will be giving you like I will be giving you the application part of it, like how to use this unit conversion basically to solve questions. Okay, so what I'm going to do is I'm going to solve few questions basically from your numerical answer type question from your GATE 2018, and I'll be telling you that how to use that unit conversion, or how to, like, wherever that unit conversion will come, there I will tell you that how to use that thing, okay, to get your correct answer. Now I will be using, like, I'll be solving few questions only in this particular video because of the time, like, because the time is not, like, I cannot make a video much longer on YouTube. So what I'm going to do is I'm going to make a course on Unacademy, and over there, question by question, I'm going to give you all the answers, especially of the physical chemistry part for your GATE 2018 exam. So I think that will be good practice, and that will give you a lot more help for preparation of GATE exam, right? So let's start with this particular video. So over here in this particular video, in this question, basically I'm going to take this 43, question number 43, and it was for 2 marks, and it is numerical answer type question. So it says that the rate constant for of a first order reaction, the reaction is like this, that your x is getting converted into y. So your rate constant is given by this, that is 1.6 into 10 to the power minus 3 per second at 300 Kelvin. So this is the temperature given to you. So given that the activation energy of reaction is 28 kilojoule per mole, and assuming Arrhenius behavior for the temperature dependence, the total time required to obtain 90% of y at 350 Kelvin is, okay. So there are certain things which are given to you. I'm just going to write all of them. Okay, so basically your rate constant is given to you, that is 1.6 into 10 to the power minus 3 second inverse. Okay, so that's what the unit of rate constant for the first order reaction. And your temperature is given to you, that is 300 Kelvin. Okay, now the second temperature at which you have to calculate is your 350 Kelvin. So that's how it is. And your EA, that is activation energy, is given to you, that is 28 kilojoule per mole. Okay, so basically now here you have to use that unit conversion thing, because your R value you have to put that in joules per Kelvin. So if you put this 28 in kilojoules, that will give you a wrong answer. So that's why you have to convert it into joules. So it will be 28 into 10 to the power minus 3. So 1 kilojoule is equals to 10 to the power minus 3 joules. Okay, sorry, 1 joule is equals to 1 kilojoule is equals to 10 to the power 3 kilojoules. Okay, I'll just write it. Okay, so 1 kilojoule is equals to 10 to the power 3 joules. So I'll just have to multiply it with 10 to the power 3 joules. Okay, so this is 10 to the power 3. So whenever you are going to from bigger unit to smaller unit, the power will be in positive. Whenever you are going from smaller unit to bigger unit, the power will be negative. So that's how it works. So these are the things given to you. Now if we use Arrhenius behavior, so Arrhenius equation is given by this, that is log K2 by K1 is equals to, it will be like EA upon 2.303 R, and in the bracket we have T2 minus T1 upon T1 T2. So yeah, this is how it works. So you will be having log K2, that's what we don't know. K1 is given to you, that is 1.6 into 10 to the power minus 3. EA is given to you, so 28 into 10 to the power 3 divided by 2.303. R value you all know, that is 8.314. And T1 is given, T2 is 350 minus 300 divided by 300 into 350 or 350 into 300. So that's how you can put and solve. So you will be getting like this. So you will be getting log k2 minus log 1.6 into 10 to the power minus 3, or you can write it as 0.0016. Okay, and then calculate the log of it from the calculator given to you. And on the other side, when you will solve this out, you are going to get like something like 0.696. Okay, so I have already solved and I'm just giving you the answer. So when you solve this term, you will be getting minus 2.796. So basically you will get log k2 plus 2.796, and this, because when you will solve this value, you will get minus 2.796. So that minus and this minus will become plus sign, and over here you have 0.696. okay, so your log k2 will become, when this term will go to the other side, it will become minus 2.096, or your k2 will be anti-log of this. Okay, so again you have to use that calculator. So anti-log of minus 2.096, and that will give you some value around, that will give you a value around, how much it will be? It will be 7.979 into 10 to the power minus 3 per second. Okay, so this is what you are going to get for k2. Okay, so this is how you calculated k2. Now you have to use this relation to find out the time. Okay, the time required for 90% conversion of y. So your x is getting converted into y. So initially let's take that x was 100 and at that time your y was 0. So after some time your 90% y is getting formed. Okay, so your y is 90% getting formed, or we can write it as, we are expressing the percentage into the concentration. So that means 90 part of y is getting formed. So how much x is left? So it will be 10. So always in this equation, that is for the first order reaction, that is 2.303 upon k, or k is equals to 2.303 upon t, both are same things up, and log a upon a minus x. So this, on the numerator we have initial concentration, on the denominator we have final concentration of the reactant. Okay, so always write the concentrations of reactant over here. That's what people do mistake over here. Okay, so 2.303 divided by 7.979 into 10 to the power minus 3, and it will be like log 100 upon 10. When you will solve all these things, t value you are going to get 288.63. so this will be your answer in seconds. Okay, yeah, so this is how it should be solved. So let's talk about the next question. So we'll talk about this particular question, and in this question it is said that the molar conductivity of 0.01 molar weak acid, that is HX, at 298 Kelvin measured in conductivity cell, the cell constant of 0.4 centimeter inverse is 64.4 Siemens centimeter square per mole. The limiting molar conductivity at infinite dilution of H plus and X minus at 298 Kelvin are 350 and 410 Siemens centimeter square per mole respectively. Ignoring the activity coefficient, the pKa for Hx at 298 is, so you have to calculate the pKa value. So what are the things given to you? First of all, I'll just write them. So at infinite dilution, your lambda naught H plus is 350, whereas your lambda naught X minus is how much? It's 410. Okay, the units are same, that is Siemens centimeter square per mole. And what is this? The molality. The not molality, the molarity. Okay, molarity is 0.01 molar. Now cell constant, that is L by A, that is called cell constant, and that is 0.4 centimeter inverse. So basically all the units are in your centimeter and moles and seconds. Okay, so you don't have to worry about much of them. Now what you have to calculate, what are the other things given to you? Yeah, so the conductivity of the cell, that is lambda m. Okay, it is 64.4 Siemens centimeter square per mole. So this is also given to you. Now since it's a weak acid, so what it will happen in it, so your Hx will basically break into H plus and X minus, right? So at infinite dilution, your lambda naught Hx will be equal to lambda naught H plus lambda naught x minus, if you put both of the values, 350 plus 410, plus 410 will basically give you 760 Siemen centimeter square per mole. Okay, so this is the value at infinite dilution. Now you have to calculate from here. What you can calculate is dissociation constant, that is alpha, and that will be given by lambda m upon lambda naught m. Now if you put both of these, so you will be getting 64.4 divided by 760. Okay, this value was given to you, this you have calculated, and you will get 0.084. so this is your dissociation constant. Now we will use one equation that is called Ostwald dilution law. Okay, so when we will use this, what you are going to get is, so basically your alpha is degree of dissociation. Okay, tells that how much the thing has dissociated, and Ka is called dissociation constant. Okay, so it's dissociation constant. So the value of Ka according to this Ostwald dilution law is C alpha square upon 1 minus alpha. So this thing we have all like 1 minus alpha square. So this thing we all have studied in our smaller classes, right? So we'll just use this to get the answer. So by putting all these values, your concentration is given, that is your molarity. Okay, so that was 0.01 molar using alpha value with that we just calculated, 0.084 square divided by, yeah, it's not alpha square, it should be C alpha square upon 1 minus alpha, so it will be 1 minus 0.084. okay, so just solve this out. So in the numerator you are going to get 7.056. use your calculator. Okay, so calculator is given to you in GATE exam, so be very like use that calculator with all liberty. Okay, so 0.916. so your Ka or dissociation constant is coming out to be 7.7 into 10 to the power minus 5. Now since it is a dissociation constant, since it is a constant, so you don't need to write any unit for that. Now your pKa will be what? So since pH is negative of log of H ions, similarly your pKa will be negative of log of Ka. Okay, so just put these values, so it will be like minus, and if you put, so it will be log 7.7 into 10 to the power minus 5. Solve it out and you'll be getting, see how you have to solve this. So it will like minus and will be outside, so it will be like log 7.7 and plus log 10 to the power minus 5. So 10 to the power minus 5 log will give you how much? It will give you like this, minus sign is outside, so log 7.7 minus 5 log 10, and we know that log 10 is equals to 1, right? So basically you have to write down the value of log 7.7 and you have to subtract from 5. Okay, so basically you are going to get answer of about 4.11. so remember the answer which over here, what you will get, that will be negative, and that negative and this negative will make you positive value. So pKa will come out to be 4.11. so this will be the answer for this particular question. Let's take another question and see how to solve them out. Alright, so let's talk about this question. It says that at temperature capital T, the canonical partition function of harmonic oscillator with fundamental frequency mu is given by Q vibrational is at temperature T is equals to e to the power minus h nu by 2 kBt, where kb is your Boltzmann constant, upon 1 minus e to the power minus h nu divided by kBt. Now for h nu by kBt is equals to 3. So this is the value which is given to you. The probability of finding the harmonic oscillator in its ground vibrational state is, okay, you have to tell the answer in 2 decimal places. Now first of all, the formula, these are directly for, like, these questions were asked from direct formula. Okay, so they are based upon your direct formula, so you don't have to worry about that much. If you remember the formula, you can do this question very easily. So the formula for probability is given by this, that is Nj divided by N. Okay, so Nj is the number of particle in jth energy state, and that is given by this, that is e to the power minus Ej by Kt divided by Q vibrational. So this is what it is given to you. Q vibrational is already given to you, right? Now we have to talk about the ground state. So for ground state, your energy of ground state for harmonic oscillator is half h nu, right? So in the place of ej, see, j is the level, okay, j is the energy state, so we are talking about the ground state. So in the place of ej you can write half h nu. So that means the probability will be given by this formula by now, that is e to the power minus h nu by 2 kt. How it will become? Because if you write half h nu by kt, that will be same thing, that is h nu by 2 kt, right? If you just write half h nu by kt, that is same, that is h nu by 2 kt. So that's what I have written, okay? And in the denominator, the value it is already given to you in the question, so just write the whole value in that way only. So it will be like e to the power minus h nu by 2 kt divided by 1 minus e to the power minus h nu by kt. So yeah, so this is how it is given to you. So we all know that this term and this term will be cancelled out, and what you are going to get, this and this will be cancelled out, and the denominator will come upside. It will be like 1 minus e to the power minus h nu by kt, and the value of this is given to you in the question, that is h nu by kt you have to take it as 3. So that will be, the probability will become 1 minus e to the power 3. Now e to the power 3, or sorry, e to the power minus 3, okay, because h nu by kbt we know, but here we have minus h nu by kt. So k or kb both are same thing, I'm just writing it k for the sake of like to not make you guys confused, okay? Now e to the power minus 3 you can calculate using your calculator, and when you subtract it from 1 you will get the value of p as 0.95. so this will be the answer for this question. So this was question from your quantum chemistry for 2 marks, numerical and answer type question. Let's take on the next question, right? Right. So now I'll solve this question from your thermodynamics part. Basically, it is from your phase transition. Okay, so it says that the enthalpy of vaporization of liquid at its boiling point, that is given to be at 200 Kelvin, is 15.3 kilojoule per mole. Now, if the molar volume of liquid and the vapor is 200 Kelvin, are 110 and 12,000 centimeter cube per mole. Now, these are the molar volume. Okay, of liquid and the vapor. So this is for liquid and this is for vapor. Now then the slope dp by dt of the liquid vapor boundary is, so what will be the slope for this? So that's what the people are asking you about. Okay, so basically they are asking about the value of dp by dt. Now what you have to take is, the answer should be in kilopascal per Kelvin, and up to 2 decimal places you have to give, and 1 pascal is equals to 1 joule per meter cube. So that's what you have to use. So first of all we'll just write the things which are given to you. So basically what are the things given to you? And the first thing is that your molar volume. Okay, so molar volume is given to be like 110 centimeter cube per mole. Okay, first of all you have to convert this into meter cube per mole. Okay, and why I'm converting these things, why I'm doing so, because like see, why I'm doing so, why I'm converting this centimeter cube into meter cube, because the things are in mks unit. Okay, because you are taking this in joule per Kelvin and all, so, and this is also in kilojoule, so that's why you have to convert this. So it will come out to be 110 into 10 to the power minus 6 meter cube per mole. Okay, so this is how it will be converted. And for vapor also you have volume, the vapor for the steam it is given to you, and that is how much for gas. Okay, so that is given to you like 12,000, and this is also in centimeter square, sorry, centimeter cube per mole. Okay, so you have to convert it, so it will be 12,000 into 10 to the power minus 6 meter cube per mole. So that's how you have to convert it. Now you have to use one equation that is called your yeah, so Clausius Clapeyron equation. Okay, so if you don't know about this equation, I have made a video on it, so you can watch that video. So this equation gives you like dp by dt is equals to delta h upon t vg minus vl. Okay, so gaseous, the volume of gas minus volume of liquid. or from V2 minus V1. So after your vaporization it will convert into gas, so that's why V2 minus V1 will give you this. Now just put all the values which you just got to solve it out and to get the answer. Okay, so basically when you will solve all of these, when you will do all of these things, what is the thing you are going to get is this. Okay, so I'll just solve this out. So over here delta H will be 15.3 into 10 to the power 3. So I have just converted this kilojoule into joules per mole. Okay, and in the denominator you will be having, that will be like T, that is 200 Kelvin, and it will be 12,000 minus 110 into 10 to the power yeah, so 10 to the power minus 6. So that will get converted into, yeah, okay, so that will be in meter cube per mole. Okay, so what are the things you are going to get, just calculate it out, and when you will solve it will be like in the denominator you are going to get something like this. Okay, so let me just solve it out. Yeah, so when you solve the denominator, what is the thing you are going to get is like over here you are going to get 15.3 into 10 to the power 3 in the numerator, and the denominator you are going to get like 237 8 triple 0 into 10 to the power minus 6. So basically you can shift this decimal up to 6 decimal places. So you are going to get 15.3 into 10 to the power 3 divided by 2.378. Okay, when you will divide it, what you are going to get is this, that is 6.43 into 10 to the power 3. So I have not used this 10 to the power 3. Now it will come out in joules per Kelvin and per meter cube. Okay, now in the question it is given to that joules per meter cube, 1 joule per meter cube is equals to 1 Pascal. So instead of this joule per meter cube, instead of this you can write it as Pascal. So it will be 6.43 into 10 to the power 3 Pascal per Kelvin, and 10 to the power 3 in like 10 to the power 3 Pascal can be written as kilopascal. So basically what your answer will be, that will be 6.43 kilopascal per Kelvin. Okay, so this will be your answer. So the answer will be this, that is 6.43. So this will be your correct answer for this particular question. Now let's take one more question, and that is from the quantum part, and this is a very easy question. Okay, very easy question. What it says, that if molecule xy, your psi x and psi y denote normalized atomic orbital of atoms x and y, the normalized molecular orbital for xy is given by this formula, that is your this, that is psi plus is equals to 0.56, and over here you have psi x plus 0 sorry plus psi y. Okay, so this is what it is given to you, the value of overlap integral of psi x and psi y. So you have to tell the value of overlap integral. Okay, so yeah, let's try to solve it out. So it will be how much? So first of all, just write this wave function in this form, that is 0.56 psi x plus 0.56 psi y. So you can relate it with this, that is psi is equals to c1 psi a plus c2 psi b. Okay, or psi 1 psi 2, whatever the way you want to write for molecule AB. Yeah, so basically the equation to calculate your like the overlap integral, the equation is this, that is c1 square plus c2 square plus 2c1 c2 s is equals to 1, and this s will give you overlap integral. So c1 is 0.56 square plus 0.56 square, c2 is also same, plus twice of 0.56 0.56 s is equals to 1. When we will solve this will be like 2 times of 0.56 square and plus 2 times of 0.56 square, s is equals to 1. So s will be 1 minus 2.05 0.56 square, that will give you 0.6272. so that will go to the other side, and it will be like it will be negative, and this term which is on the multiplication of this, that is same, so that will come in denominator, so 0.6272. so when you will solve this, when you will solve the numerator and the denominator, so basically what is the answer that you are going to get is 0.59. so this will be your overlap integral. So like this you have to do this kind of question. Okay, this was from quantum chemistry, 2 marks question, numerical answer type, very easy to solve. I'll take one last question for this particular video, and the rest of the question I'll try to post them quickly or very soon on Unacademy. Okay, the link for the course or the link for the course will be given to you in the description. This is the same course where I have uploaded solutions for CSIR 2018 December exams. So in that only I will include these exams, like these videos also. So the link will be given in the description. Okay, you can just go to that link and watch those lesson out. Okay, and that will be provided in both languages, like Hindi and English both. So yeah, let's move on to the last question for this particular video. Okay, so I will take this last question, and it was from your atomic chemistry. Okay, so it says that the pi electron of benzene can be modeled as a particle in a ring that follow Pauli exclusion principle. So now what they are saying that the pi electrons, you have to take them as a particle, and that follows Pauli exclusion principle as well. It is given that the radius of benzene is 1.4 angstrom. This is given to you, and the longest wavelength of light that can be absorbed during the electronic transition in benzene is, so that's what you have to tell, and you have to tell up to 1 decimal place. Okay, now you have to use mass of electron as this, that is 9.1 into 10 to the power minus 31 kg. H value you have to put at 6.6 into 10 to the power minus 31 joule second. C you have to take as 3 into 10 to the power 8 meter per second. So what is the equation you have to do? Now I'm not going to write all of these things, but the radius which is given to you is how much, that is how much that will be. Yeah, so the radius given to you in the question is 1.4 angstrom. So basically that will be like 1.4 into 10 to the power minus 10 meter. You have to convert that into meter, right? Now for longest wavelength, your equation basically is this, that is hc by lambda is equals to h square, or yeah, so basically it is your h cross square by 2mr square, and this is given by n2 square minus n1 square. So this is the equation to calculate lambda, that is wavelength. Okay, now h cross we all know that is h over 2 pi, so it will be like hc by lambda is equals to h square upon 4 pi square and into 2mr, and over here we will be having n2 square minus n1 square. So what you have to do, what you have to put, so all the values you are already given with, just you have to decide what will be n2 and n1. So your longest wavelength will be when your energy levels will be like, the energy difference should be least, and that energy difference will be least when n is equals to 1 and n is equals to 2. The transition will be done between n1 and n2. Okay, so for least energy your wavelength will be high. So that is how energy and the wavelength are related to. So n2 will be 2 and n1 you have to take as 1. Put all of these values, so you basically your 1h will be cancelled out like this, so you will be getting c here. So 3 into 10 to the power 8, so 3 into 10 to the power 8 divided by lambda, that's what you have to calculate. H is 6.6 into 10 to the power minus 34 divided by 4 is like that only. Pi is your 3.14 square, then your 2 is like that only. M you have to take as 9.1 into 10 to the power minus 31, and that is what given to you in the question. R is your 1.4 into 10 to the power minus 10 square of that, right? So because here it was a square, okay, so I just missed it over it. And in the numerator we will be having 2 square minus 1 square, because I have taken n2 as 2 and n1 as 1. Why I have taken, so I have already explained. So when you will solve all these things, when you will do every solution like correctly, you will be getting lambda is equals to 213.2 into 10 to the power minus 9 meter. Now it is in meter, you have to express the answer in nanometers. So basically your answer will be 213.2 nanometer, and just you have to give the answer up to 1 decimal place. So this will be your correct answer. So that's all for this particular video. I hope you guys like this. I hope you guys understood it well, and if you want to ask anything, you can ask me in the comment section. The link for that course I'll be giving in the description, and also I'll be doing, like, I'll be pinning out that comment, like I'll be giving in the comment box as well, and I'll be just pinning it out. So you'll be getting the first comment will be the link for that particular course on Unacademy. Okay, you have any doubt regarding GATE 2018 or any particular question which you want me to solve in the next upcoming video,
I'll be very happy to do that, and your suggestions or your requests are most welcome. Thank you so much for watching. I hope you guys liked it, and if you like this video, give it a like, share it with your friends, and subscribe the channel if you are new to the channel. Okay, so that's all for this video. Bye bye, take care.